Welcome back. Today I'm going to go over histograms. So for the agenda, I'm going to first talk about continuous versus discrete data. Then we're going to jump into the topic of today, which are the histograms, and we're going to go over examples on how to make them using given data. So let's begin here. I have continuous data and I have discrete data. What is the difference? Well, here we go. For discrete data, we can say that it is a quantitative data. So quantitative, again, is numerical. We have numerical data, which is based on counts, can only take on certain values. So what exactly does that mean? So let's say, for example, you're watching a boxing match, and suppose that your job is to count how many punches fighter A delivers onto fighter B. So here we can count that. Let's say that we have fighter A and then we have fighter B, and let's say that fighter A landed 20 punches on fighter B on round 1. Here we were able to count this. There's no such thing as a 20.1 punch, right? There's no such thing as a 20.7 punch. That doesn't count, right? There's no such thing. So here we want whole numbers, whole things that we can literally count with our fingers. So that's more or less what discrete means. Now to talk about continuous, again we have quantitative data, so numerical data that can be measured. And here it can take any value within a range. And here's what I mean. So for example, let's say I have 2, and then our range is from 2 to 4. For continuous, we can pick any number in between our range from 2 to 4. So here we could choose 3. But we could also choose 3.5. And notice that for discrete, that was not allowed. Decimals weren't allowed, only like whole numbers that we could count. Here, decimals are fine. Those can still be measured. And for continuous, it gets even better because we can be more precise here. We could have chosen 3.51 or maybe something like 3.51257, etc., etc. And for continuous, we basically have infinite possibilities here. For discrete, that can also be possible. We could have a infinite set of discrete values, but for continuous, we can have a lot more values since we're including decimals. We can get fractions, irrational numbers. So more or less, that's a basic explanation of what discrete and continuous mean. The definitions can actually get very, very technical, but I think we can run with what I've shown you here in these past couple of minutes. Let's organize everything that we've learned up to this point. So here is a concept map. Here are the types of data. We have quantitative, which is numerical, and then we have qualitative, which is categorical. And for categorical data, remember that bar graphs are king when it comes to categorical data. And for quantitative data, we just learned that we have 2 types. We have continuous and discrete, things that can be counted with our fingers, and things that can be measured, such as decimals, fractions, etc., etc., etc. So let's take a look at some examples. So here it says, state the type of data, continuous or discrete, and explain your reasoning. So A, number of text messages. Is it continuous or is it discrete? I say this is discrete, and then here is my explanation. So you can forget to add information on a message sent, but that would force you to send another message to complete your sentence. You would be sending a total of 2 messages, and in this scenario, you can't send 1.5 messages. There's just no way. 1.5 messages does not exist, which means that messages are getting counted. So number of text messages, we're gonna go with discrete here. Now let's take a look here, the weight of a newborn baby. here I go with continuous, and here's my explanation. Suppose the range of the average weight of a newborn is between 5.5 pounds and 10 pounds. Here we can be very precise with the weight of a baby. A baby can weigh 7.23 pounds. So here we can measure the weight. On top of being able to count it, we can also measure it and be as precise as we want to be. So using these two examples, do the next a set of problems on this assignment, and then I'll see you back for the histograms examples.